Would you like to buy some crypto? Yes, I'd like to buy some crypto. Hello, boys and girls and germs and parasites and whatever else the hell exists out there. Now, something which I wanted to do. Oh, look, there's no corner cam. Ha ha, because I don't care. It's just, this is easy. I got the alpha up here. All right, so let me grab my caliper. Something which I wanted to do for a while is I wanted to demonstrate some cables to you, okay? And I wanted to make it exciting. So first of all, let's take a look at 3 common cables. This is your typical cheap, shitty indoor Cat 5e. It's got your twisted pairs in it, right? And let's take a look at these guys for a sec. We'll do a full comparison after, but I'm going to set this for, where's an inch? There's 1 inch right there. Okay, so TPI, twist per inch, is usually how we can gauge Cat 5 and Cat 6. So I'm going to be lazy and at the same time help you guys learn on your own. Check this out. Let's see how many twists per inch we have on this Cat 5e. We've got 1, 2, 3 twists per inches here. But look at the brown. The brown has 2. Kind of weird, right? So anyway, notice that there's no shielding. We've just got our, what gauge is this? It usually says on here, I believe that this is 22 gauge, I think. But the next step I'm going to do is I'm going to tear it out of its jacket if I can. Hello, I am strong. Rawr. Okay, so now you'll see what I'm going to be doing in a minute. So we've got this one. Okay, so I'm going to put these guys aside over here. And I'm going to take a strand off unceremoniously. I'm going to put that one over there. Okay, great. Now let's take a look at another one. Let's look at some standard installer cable. Maybe this one will have the wire gauge on it, but you'll notice that it's almost the same. The big difference is that the jacketing is a little bit heavier and it's waxier, right? That's a big deal, by the way. Keep note of that, okay? So anyway, let's see here. You've also got your ground lead, or your drain wire as they call it, and there's a foil shield here which helps keep electromagnetic interference, EMI, out. There's also a plastic wrapping on the cable, but there's no core. Okay, you see that? There's no core. Now you're also going to notice these guys are kind of hard. Okay, and I'm going to put, I want to put these 2 blues next to each other for a second because I'll do a little comparison for you. Now this outdoor claims that it's Cat 5e as well, but you know what's really interesting? This Cat 5e, which is, I think this is just cheap CommScope. No, it's Ubiquiti Tough Cable Pro, the installer cable. Let's see how many twists per inch this blue has. Okay, so we got 1, 2, 3, 4. Oh, there's no more twists per inch in this. I wonder if it might be Cat 6 labeled as Cat 5. Well, I guess we'll never know unless you guys go and look it up. Go look it up. So I'm going to pull the jacketing on here now that you guys have had a chance to see some installer cable. And I'm going to grab a wire from this one. We'll make this one. The first one was orange. I want to make the next one blue. Come on, get off of that. Get off of my cable. There we go. Take the drain wire too. Get that off of there. Let's get rid of this plastic. I'm going to have such a mess on my floor. All right, here we go. Now I've got the blue. I'm going to take blue. So the orange was off of the very, very first indoor. Like, look at the, you can feel that this is a heavier gauge, and it actually has a heavier jacket. It's just a much heavier cable, this cheap installer cable versus the indoor cable, right? Oh my God, gosh, do I actually have to do this? Do I have to like, spin it? You spin me right round, baby, right round. Yeah, that should be enough. All right, there we go. Some of you might have already guessed what I'm going to be doing with this shortly. It's blue wire, ha ha ha. But I can also keep this little piece right here and use it as a comparison to our next cable, which is simply Ubiquiti Tough Cable Carrier. Now this is not your standard installer cable. This is the kind of stuff that we put on towers. Now you look, we've got our black heavy jacket. We've got our braid wire here, which is for electrical protection, right? And look at this. Actually, if you take all this stuff and spin it together, it comes out to roughly about 12 gauge, 12 AWG. Here's a drain wire. Now you notice this has a hard plastic core separating the 4 conductor sets, okay? Then there's a plastic film, and then there's also this neat foil on the inside of it, right? And if you just nick the foil, by the way, like so, if you nick the foil like so, it will rip easily, and you can slip it off. And then same kind of thing with this plastic. It sloughs off just like you've got a radiation burn. All right, cool. So now we've got the cable exposed, and let's do another comparison. I want to compare the Pro to the Carrier, and it looks like exactly the same cable. The major difference is that it has a divider inside of it, has this nice heavy shield, this braided shield, and yeah, everything else it seems to be pretty much the same. So now I'm going to take a piece of this cable apart. Honestly, if they're the same, I probably don't need to do this, but they do look identical. There we go. We can now take the ground off of here. I'm going to get slivers. I'll go over there. That's all going to go in my copper bucket, because here in Canada, copper is worth quite a bit of money. You could say you can make more money off copper than off minimum wage. All right, here we go. So now let's take green for this one. Yeah, we'll take a green off of that. Let's do a quick comparison again. Let's see here. 1, 2. The blue definitely has more twists to it. I'm going to grab this blue from here. I'm going to just see something. We're just doing a little analysis here, right? Okay, so it looks like the blues are exactly the same wire. Let's just see if the greens are too. Here's the green from the other cable. That's from the standard indoor. I guess I'll have to use... Oh, there it is. It's over there. There we go. This is very interesting analyzing this, right? Let's see here. The greens are exactly the same as well. But what's interesting is the greens even still have less twists. They've only got 3, whereas the blue have 4. Isn't that interesting? Okay, so it looks like these 2 cables are identical. So realistically, I only need these 2 wires here to do the tests that I want to do, because the Tough Cable Carrier and Tough Cable Pro, only major differences is that you've got your shields. All right, so let's see here. What are we at for time, by the way? 7 minutes, 7.5 minutes. Cool. So I've rigged up this little demonstration board here. It limits out at 5 amps. I can't go much higher than that. But the idea is I want to see. I wish I had a thermal imaging camera too for this. Can somebody buy me or give me an old thermal imaging camera so I can, like, preferably one that's got HDMI on it or something? I don't know. Because I'd love to be able to do destructive testing. And oh, I put it on the wrong way. Sorry. There we go. It's been a long time since I've done telephone jacks. There we go. We'll just stick this in here like so. So you can probably guess what I'm getting at here. I want to test and see how much current we can get across one of these wires. 1, I want to see the losses that we get, but 2, I also want to set it on fire, because, you know, I like that. I could take up a little bit more. Yeah, that should be good. There we go. We'll wrap that around. There we go. So next to me, right here, let me just adjust the light. There we go, so you guys can see it. So now you should be able to see the voltage and the current on here. So I'm going to turn on my PSU. This guy maxes out at 5 amps, so I'm kind of stuck that way. So our 54.4 volts, and let's dial the current up. So I'm going to stop first at 1.25 amps, which is roughly BT. I'm not feeling any heat on that. You know, I thought I had a thermal probe for my multimeter, and I don't. I should have ordered one for this video. But, hey, who cares? Whatever. I'll just trust me. I'll tell you when it starts getting hot. Alright, look at that from working today. Let's dial it up to... Let's dial it up to 2 amps. Okay, 2 amps. Am I feeling nothing? I don't think it's getting warm yet. So, but the resistance is going way up. I'm at 27 ohms for just a 1-foot section, right? That's crazy. At 2 amps, 20 6.5 ohms. Wow. Okay, so now let's dial it up a little bit more. So we're at 110 watts, by the way. Here we go, 3 amps. That is warm. That's noticeably warm now. Okay? So this is the indoor. This is the white indoor Cat 5. Like, it's not hot, but it's warm. Okay, let's take it up to 4. Here we go. We're at 13 ohms. Woof. Yeah, that's getting hot. So at 4 amps, that is getting hot. Let's dial her up to 5. Just a touch more. .9. It's getting warm. It's not hot, but it's definitely getting warmer. That's 10 ohms resistance now. So we're pushing 265 watts for this tiny little piece of wire. And it's almost as warm. I don't want this. This thing's getting really hot, so I don't want that distracting me. I'm going to put my cheek on it. I would peg it at about 40 degrees. Probably about 40 degrees. Alright, so this one does about 40 degrees. So now, you guys probably want to see something a little bit more exciting. Let's see how much current it takes to actually, blow it up. Okay, so I'm going to just dial this right down to 0. Cool. Now I'm going to grab one of these guys here. And I'm going to remove my load tester here. Let it cool down for a minute. Whoops. That didn't zap me or anything. I literally just got startled. Alright, so I'm going to go straight to the power supply. Oh, shit. Okay, I'm going to have to turn this off first. I'm not sure if it's going to like me for this. No, it just goes to... hold on. Let me see if I can do this. Alright, so, how am I going to do this? Because I don't want to blow up my multimeter, or my power supply. Let's set it for 6 amps. See what happens. Alright, there's 6 amps right there. That is hot. Alright, let's dial it up even more. 8 amps. Cool. Let's see if I can get it up to 10. Okay, there's 10 amps. And, you know what I'm going to do? I just got an idea. Here's what we're going to do to try this experiment. I'm going to take this off. I'm going to put it back on here. And instead of running it at 54 volts, I'm going to run it at 20 volts. And then that way I can really dial the amperage up. Because this guy is limited to 270 watts, right? Okay, so first, let's just jump right in. And this is a proper load. It's not a dead short. Oh, doesn't like being at 9.7. Okay, let's try that again. It's supposed to be 270 watts capable. Wow, so 10 amps is the most it'll do. I can bring the voltage down, actually. That might do it. Let's go 12 volts. Because that'll keep the wattage down, right? I think it'll still top out at 10 amps, though. Which is ironic, because the actual board's set up for 50 amps. It's supposed to be able to handle 50. 9.7 amps. Huh. Well, that's annoying. Okay, well, I guess I could put a resistor in line with that at ballast, just to make it smoke. Or you know what? Hold on. We could just put 30 amps through it and say screw it. Because so far, I'm not able to make it smoke that way. Alright. Let's have some fun, folks. Some of my favorite words ever have always been, oh no, I popped it. Nice silicone leads here. Is that battery dead? Really? It's supposed to be a car battery. There we go. Yay! Phosgene. There. I melted it. Okay. So that's one down. Alright. So now let's take a look at how much stronger the this guy is. Because this guy is way crazier. Like, this is way tougher. It's definitely a larger gauge. And we'll find out what gauge it is in just a second. Okay, so let me get my calipers again. And this one is about let's see here, 0.5 mil. This guy. Yeah, so this guy here is about half the diameter of the tough cable carrier. Well, the Ubiquiti tough cable. Alright, let's do this. I was really hoping that this video would be a little bit more exciting. I should get a bigger one of these. I mean, I'll look into it. I'll see if I can get like a 30 amp one for doing dummy load testing. It's just this one wasn't bad. Like, I bought it a few years ago and it only cost me like, I don't know, like 50 bucks on Alley. Here we go. Alright, so we're going to do the same test I just did with this guy. Alright, so let's do... I'm going to take it up to 60 volts so I can try to get just a little bit more juice out of it. Alright, now let's dial this back. These two. There we go. So we've got 60 volts going through this. So let me take this up to 5 amps. Because we already did the test on a finer gauge cable, right? So... Alright. Yeah, 270 is where it maxes out. I could put a light bulb in line with this. Yeah, it's getting warm. Let me do the phase test. Yeah, it's getting warm. It's not hot, it's warm. So I'm putting about 256 watts through this thing right now. Cool. So, yeah, there we go. There's some tests with some Cat 5 cable to see what it can do. Now I'm pushing 5 amps at 60 watts through that. 255, or sorry, I'm putting 5 amps at 60 volts through it. So that's like 254 watts going through this right now. And the resistance on this guy at that is, let me put it back to the proper voltage. Yeah, so 12 ohms. Cool. There you go. I don't think that was a very exciting video, but hopefully some of you guys found it interesting, and hopefully some of you guys found it useful. But, whatever. I think I'm going to nuke this wire. Let me see if I can just do it with my welder. Hey, you know what's really cool? Did you see that? Let me just do something here. The wire actually jumps when the current goes through it. See that? I'll bet you that it's there's an electromagnetic pulse going through that. Watch this. Yeah, look at that. See that line that showed up? That line that just showed up is a electromagnetic line. Watch. Cool, eh? You can actually see the second that the wire jumps, you can see the line form, right? Isn't that cool? So there you go. I hope that was educational or edutainment. Edutainment? All right, I'm just gonna. So anyway, I hope you guys had a great time. So have yourself a great night. Thank you for watching. And don't forget to like and subscribe and tell your friends. And if you want to help support me, jump on the Patreon. Anyway, see you later, guys. I'm going to go take a nap.